Hello class, Dr. Mike here. This is topic 5 or chapter 5 from the textbook on networking and server attacks. So I'll be focusing on just some of the parts of the chapter. I definitely look at the chapter, look at the summary, and definitely look at the whole chapter if you can. There's some good information here. I'm going to give you some external resources, especially when it comes to cross-site scripting, cross-site forgery, injections, and so on. But look at the chapter to get full information beyond what I'm going to show you here, which is just a summary. So, networking attacks themselves fall into two groups, generally two groups, and there's a lot of overlap here. But there's the interception and the poisoning attack. Interception is pretty straightforward. This is, as you can probably guess, this is what we know as our man in the middle, or man in the browser sometimes. We'll talk about that in replay attacks. Replay attack really is just sort of something that comes from this situation, which is called man in the middle. If I can somehow insert something, it could be capturing traffic, it could be a rogue server, it could be a proxy connection, something that will capture information going back and forth. I can become this sort of in the middle of the transactions, and I can capture those. Of course, you can guess right away. The easiest one would be capturing Wireshark traffic between two non-secure endpoints, the client server. Now, of course, man in the middle would be a Wireshark, and there's really nothing else to do. Now you can get more advanced than that, and we'll see. A lot of times you might actually be on the client side and implanting on the browser or a browser attack using something like Beef with a hook.js. Among other things, macro viruses, things like that to get in here. And we talked about that before in previous chapter. Somehow get an attack in on the client side to allow me to establish something on the browser. And that's pretty important because this does allow replay attacks, for example. But even more important is I can then get my hands on public-private keys and everything goes back and forth. Well, public keys at least, or if I can spoof myself in there. So there's a lot of ways to do this. Look at the textbook, but again, probably the Trojan infection, social engineering, try to get something on the browser, maybe malicious extensions to get that. So replay, again, is a way to sort of capture that data going back and forth. A way to protect replay is to have a session ID that's a random session ID. That's established for only that session, for those transactions. This is on the server side. So we'll see also where this session ID, if it's not unique or if it's not used improperly, we can also use in different attacks. But there's prevention methods to use for that, so something to check for. Poisoning, this is where you do get access to, a lot of times into a DNS or ARP server. And we can actually create redirects to become man in the middle. I'm going to talk about privilege escalation in a second, though. Let's go over the poisoning. Both ARP and MAC, I'm just going to use the next slide here, really is for this. Steal data, man in the middle. This is definitely where we get our MAC address. We substitute MAC addresses, or we get DNS entries rewritten to allow change of traffic. And this is a sample host file. And really, if I can get into a DNS server, and you can see by this slide, this is figure 5-4, I can redirect traffic to my own server. And from there, I can do anything with it. And of course, this evil.net server, I could stand up a fake endpoint, either for an actual client or maybe an API endpoint where there's little security, or I don't require much security. That is, I capture information coming in. Those captures could be keys, login information, it could be actual data, that could be customer data, it could be sensitive data to the company itself. So DNS server security is very important. Privilege escalation, this is definitely one where, especially with the browser-based man-in-the-middle attack, you somehow get onto or into a system and you can get vertical and horizontal. Vertical is pretty easy. Maybe somehow I come in as user Mike, and I somehow, it could be through a lot of methods. It could be buffer overflow, maybe having a guest account allows me to inject some sort of exe that will buffer overflow, and that will dump me to a root terminal. Root terminal being root access or administrator prompt, for example. That could be one type of attack. Another one, of course, is from the browser itself. I've seen things where a cookie that had an unsecure cookie that held information about the user's privileges. And so a cookie change, a real easy cookie change using like Burp Suite, I was able to unlock a whole panel on the web page showed up that had a bunch of admin functions. So that was sort of hidden away, it'd been like in a space over here, for example. So vertical is straightforward though. Come in as a lower end user and a regular user, and in somehow getting root. So of course root or admin being the key here. Now horizontal is one where I come in as user Mike, and through some method I become another user. And this is not root user, this might be user Bob. And with that same method I can also become user Lisa and user Kim, and transverse through different user accounts. One way I've seen this before is like with our web browser. Something as simple as maybe UID is up there in the URL bar, or it's passed in a cookie that's unsecure. And my session is not secure with a unique session ID. So bad session management. And I can simply just change this value here. Again, this is not 1, 2, 3, 4, 5, 6 here. This is not a user ID, but I could change the value in the URL and see what happens. And I see myself able to just change that value. So using like Burp tool, I can set up a quick loop script there and just start at 0, 0, 0 and go through like 999 and easily grab 1,000 user accounts. Maybe the page itself has information about the user account, like your sort of like user preferences or user account page. So I go to my user account page, authenticate as Mike, change the value, and see what happens. So simple test. Now you need a web browser. Now, of course, to scrape the data, you need to apply something like Burp Suite, or you use a Python script to scrape that. But horizontal can actually lead to basically a data breach per se, where to get information off about end users. So something easy to test for, but also something to very want to consider to look for. And then if it does happen, look at how we handle session management. Server attacks. All right, so we talked about some of these already. Denial of service is probably the one that most people know. Ddos, distributed denial of service attack. This is famous with the Xbox hack, PlayStation, Xbox going down on Christmas years ago, for example. DDoS really is a political statement, or more like it's you bringing a system down. It's pretty obvious. Things should go off. Alarms will go off. Sometimes they're very political in nature. There's ways to protect from DDoS. A lot of times you might run something like Cloudflare. And when some web services have some sort of intermediate layer that helps protect from denial of service, they can see those sessions. But still, it can be very hard to defend against. We talked about hijacking already a little bit. Again, coming over hijacking. Let's talk about from like a web browser. Overflow attacks, buffer overflow. Web server attacks. We're going to look at this real specific here, really specific. There's some ones here I want to bring out to highlight. I talked about DDoS already, so we'll go through that. Again, look at this, DNS amplification, send flood. DDoS has different flavors, so defense of each type is be a little different. Zero-day attack. This is a review here. Sometimes only known about. But let's talk about some important ones here. Injection attacks and cross-site scripting attacks. All right, so cross-site scripting. I'm actually going to show you some resources here to help you explore this. This is where I tell the web browser, and it could be on the victim's machine, to run a script from an external source. By nature, web browsers will just run what they're told. So if I can get the end user to run a script, now that script could be malicious in nature. It could be from an external source, my own web browser. And so again, there's some stuff here to understand. Of course, cross-site script needs to meet two criteria. It needs to have the user input without validating it, and needs user input in a response. So what could you stage one of these attacks at? Something like a page that has maybe a place for comments. So look for comment fields, places where people can post things about themselves maybe, and then be able to embed a cross-site script attack inside there. So before I go on to cross-site script request forgery, let's show you this resource here. This is called OWASP. Look for the OWASP top 10. So this is probably going to be your best resource as a security engineer, security professional, especially dealing with web-based interfaces. And really a lot of stuff is facing the web. And this is going to give you a great, what is the top 10 issues now? Injection, we'll come to that in a second. Cross-site scripting actually has rolled down to number 7, so it used to be up in the top 5, I believe. So again, this gives you the definition. You can look at owasp.org, Google OWASP top 10. And this is a great place to start looking for issues. And use this for your internal evaluations. If you're a pen tester, it's a great place to look for pen testing. Security misconfiguration is another one. I have my dissertation is built off this, in fact, number 6 here. It's been there since, past 5 years. Even when I finished my dissertation, this was in the top 5, top 6, so it hasn't changed. But cross-site scripting, we can actually bring this up here. It's going to tell you exploitability, the weaknesses, and I'll even give you examples here. Now, the textbook has examples too, so definitely look at that. But you can see here, the attacker can modify a parameter and tell to run a script. And that's what the key here is, the script tagging. And the browser itself, in this case, we're actually injecting this script to run from an external source. In this case, it looks like we're actually grabbing the cookie information. So this could funnel back cookie information to an external source. Those cookies can be secure, could be used to implant the browser attack that we saw in the previous slide. So this is a great resource here. OWASP top 10. Now I think it's not on here anymore. External XML, external entities is new. Request forgery has come, probably fallen off the list. Definitely it's still in the top 20, I believe, but it's a harder attack to pull off. The idea being, I know my end user maybe goes to chasebank.com. I know they're a Chase Bank user, and maybe they're one of those users who leaves 1,000 tabs open and stays logged in forever on them. And my hope is, again, having a browser-based attack that somehow get maybe a session on their browser or through a cross-site script, I can send their browser to go ahead and do a certain list of actions against my Chase Bank, which can be transfer money from checking to a third party. It is a very hard attack to pull off, and the way to prepare it is using cross-site script forgery. There are XFRS tags on the field. Basically puts a unique value in the field for that browser session, where if someone tries to say, yes, transfer $1,000 to Dr. Mike, that session that comes in has been sort of replayed, doesn't have the right tags. So, and the important things with cross-site scripting, XFRS, and also Sql Injection is the defense of it. And that's another good thing here I'm going to show you here. And let's go into injection, which of course is still number 1. And you can see here, this is our injection attack. This is still one of the biggest issues here, specifically SQL injection. And there's some examples here. And the best part about OWASP, going off the slide for a second, I'll come back to it, talk about injections, is if you work with security professionals, a development team, and you do a test and say, well, you can do cross-site scripting. Well, okay, what does that mean? Well, here's what it means. Here's what it means as reflected and stored. Stored's the worst kind. Maybe our website stores a cross-site script. So an important aspect of injection and cross-site scripting is we don't check user inputs and we don't check outputs to the user. Very important. That's an important aspect of that. We trust anything the user sends us from their web browser. And we just trust anything coming out of our system to the user. We don't have any kind of filter in place. So, and people say, what does that mean? Well, it means that someone can put something on our web page that will have an attacker, again, maybe load a script, and when he visits the comment page, automatically is owned. Their browser's owned. And so you might be asked, well, how can we defend against that? Well, here's a good part about this. This is where OWASP comes in. There's prevention cheat sheets. You don't have to become an expert off the bat, understand every aspect of cross-site scripting. What prevention model should we use? So again, we should not trust anything the user sends us. The idea is untrust everything. Anything that comes from the world, end users, APIs, whatever, don't trust it, especially if it's going to be inside a script tag. And the best part is this is not new. There are built-in cross-site scripting libraries. So in this case, here's one from Microsoft. Java Encoding Project has one. So now we get to the developer land. And the best part is if you can show we have a security vulnerability, here's the risk it brings to us, and then of course the developer team like, well, can we defend against it? Well, here we go. There's actually a library that's, let's say we use a Microsoft code on our end. There is from Nugget here, it looks like, okay, down from Nugget, anti-XSS. There's also a bunch of these for Java. And the idea here is we can bring those into play and load those in, and those should take care of that. And you can make your own. You can put in your own regex, sort of blacklist, certain types of comments. Don't allow. Example, I don't allow a script tag anywhere in a comment block. Things like that, and also look at the actual end framework. Whether it be maybe a WordPress site, they might have some sort of ways to disallow certain types of characters in a field. So you might have seen this before too. Just as a regular end user, you might try to type something in and it says, "We don't allow that character." So again, the thing about this is these prevention cheat sheets. It's going to give you help in both testing and sanitizing inputs. And that's the key here. Sanitizing inputs and sanitizing outputs too. So I went off there a little bit, but these cheat sheets are fantastic. This is going to help you communicate out the risks and the way to prevent it. Now, injections, that Sql injection is probably the number one. Again, I'm not going to go back here. You can see really his idea is Sql injection really is like a cross-site script, but what it is, it's a field that somehow reaches back into our database. A good example of that is a search field. Search for a product, search for a phone number, search for something. So maybe it's a product search on the web page. If you're security minded, you should see that on the screen and go, oh, I'm going to look for that. And then see if I just pass in certain keys, do I get back anything? Like this right here. If I pass in a certain list or a certain set of keys, and there's actually, there you go. Name and passwords are good to give into. Here we go. So if I pass in an and equals 1 or 1 equals 1, you can see these different type of things. Do I get back a database error page? Do I get back a database dump? Or do I get back a good error page saying we don't allow that? That is not correct input. The latter would be the best, of course. That means it's protected. Or you get back nothing. You get back a blank page. We just sort of dump that input So we dump this, we dump that. You can see that right there. We basically take the ID from the URL and we dump in a database call. So that's a quick, easy to test for. And there's great tools for this. OWASP Zap, I believe, has it. Burp Suite, a good one, and a SQL map. So there's ways as a defender you can check these pages. And there's ways as a defender also you can prevent these from happening. And again, cheat sheets are here. Injection cheat sheets, prevention cheat sheets for Java, and so on. How to do parameterization. That's the key here, is we want to parameterize. Anything that comes in, we don't feed this directly to the database. We send it to a framework that it's called parameterization. And either will blacklist, and it will just comment out, or sort of sterilize that input. And possibly log it, of course. That's actually even better. You just don't want to dump it. You want to log it with the source IP and things like that. So SQL injection still is number one. When you see stuff on the news, a lot of times an injection was the vulnerability that got into this. So, and this comes through simple attacks here. Hijacking is one of them. URL hijacking, click jacking, domain jacking, and so on. Before we move into that though, again, go look at OWASP top 10, still number one as of this recording. Injection, top 10. Broken authentication, that's with session management, and that goes back to, we talked about, horizontal or vertical escalation. APIs just dumping data out. And of course, this misconfiguration is a huge deal. So that's some of the ones the top 10 to look at. For the rest of the stuff here, URL hijacking, session hijacking, domain hijacking. Again, cross-site script, you can do session hijacking, taking cookies from the victim and reusing them. Session keys, things like that, guest tokens. Hijacking or bit squatting. Again, Frugal or Google, right? So we've seen this before too. You might have typed in too many O's for Google. Always look for that as a defender. Is there any other misspellings of our company's name out there? Someone's sitting on that domain. Because they can use that to create a fake site and then again fool the end users. That's also domain hijacking. We basically change the domain pointer. DNS again, so go to DNS providers. Maybe someone can get in and fool the DNS provider and repoint from your company to a evil server per se. Hijacking clicks. So there's ways to put, we call it 0 pixel iframes over web browsers. Iframes shouldn't be used too much anymore with HTML5, but we can actually do entire HTML overlays. So there's ways to actually create almost a fake page on top of a fake page and feed that in and steal the clicks. So overflow attacks, this is actually covered in a separate lecture. This should have been in separate chapters. The big one being buffer overflow. This gets down to code security. Basically, if I only take in 64 characters and I give it 120, what's going to happen? It should not allow it, right? We should disallow that much, but if it just takes it, it overruns the memory and dumps out. And again, you can see here. And the idea being it could cause it could be a new address pointer to some malware code, or really a buffer overflow. It dumps out and it doesn't handle the overflow, and it leaves you with a prompt. And that's what the biggest thing is. Somehow, if I overflow a service, maybe FTP service, web service, an API service, something, a service on a server, how does it handle dumping? Does it dump me to a prompt? In this case, that would be definitely bad. So that's a few things here before we wrap up here. Malvertising and ad fraud. Again, ad servers. This is again back to poisoning the well, the ad server attack. Ads themselves are not supposed to be malicious, but they're served out from third parties. I'll attack the third party, and that'll give me a larger pool of possible victims. And another thing too, as our browser, it really is our most used app probably for most people. And extensions and plugins are great. And this is a place where you've probably found stories where there's been malicious browser plugins. So be aware. On a personal note, and also it would raise awareness if you become a security professional at an institution or corporation. Raise awareness to this. It could be part of training, and possibly even if the browser is managed or the operating system is managed, maybe you search for bad extensions. You don't want to have none. I mean, some of these extensions can be very handy, very productive, but you want to make sure no one's loading any malicious ones. And that's it. So from this chapter again, understand cross-site scripting, understand cross-site scripting, understand, I'm going to go network attacks. There we go. Web server attacks, denial of serving. Web server attacks, definitely understand how this works. There's sort of stuff here about network attacks also, SYN floods and so on. There you go, cross-site scripting. There's two types, reflected and I mentioned before, and embedded. So you can see some examples of Guri here in the book, how you can just take, SQL injection, if you just take a response and trust it, it can be used in a lot of different ways, cross-site request forgery, and of course SQL injection. So, and probably again, the biggest one is this OWASP.org. This is a fantastic resource for all security professionals. Can't say not good enough about it. And it's not just a place for like spotlight on tools and things like that, or different sponsors or events. It's the actual projects. The top 10 should be your first stop. And you can see here, it is tools you can use. Actually, OWASP has ZAP, for example, but also not just tools you can use, but good ways to go ahead and help explain to you and help you explain to others the threat, how the weakness, and how to prevent it. So that wraps up network server attacks, and I hope it was helpful. Thank you.